Okay, all right, so we are actually going to do some proofs today. Okay? No, we'll ease into it. We'll start with something that's familiar. Okay? So we're going to start with algebraic proofs, and we're going to ease in to some more complicated stuff. We're going to kind of do our best to try to make this as clear as possible. So the most important thing with algebraic proofs is that you're not skipping stuff. Okay? And that will obviously be important when we're doing our other geometric proofs, when we're trying to prove different things. But with algebraic proofs, it's very, very important that you don't skip stuff, that you don't do any steps in your head, and that you do all steps based on properties. So there are certain ways that you may have been taught in the past of how to do different things, but we have to make sure that we are paying attention to, or we have to make sure that we are making our work look like the properties that are happening. Okay? It's a very formal way of doing algebra that we may not be used to because we're used to skipping steps and doing stuff in multiple steps at a time and different things like that. So just make sure you're careful. So what I want you to start with is do the exploration. Okay, you're going to fill in these justification steps over here, but I would like you to try to start using these algebraic properties of equality. You can just do POE for property of equality, but I want you to put down the addition, subtraction, multiply, divide, substitution, property of equality on these lines, okay? Another option for these lines is simplify. So if they are just combining like terms or something like that, you can just put simplify on this line, okay? All right, I'll give you a minute or two to do that together with your groups. Go ahead. Okay, so let's look here, okay? So basically what we're asking ourselves is specifically how are they going from line to line? So from the first line to the second line, what did they do? They distributed, okay, so we got that. From the second line to the third line, what did they do? They simplified. They combined the 6 minus 5, okay, so that's simplify. Okay, going from the, and they even kind of put it in bold for you, the third line to the fourth line. Good, subtraction, property of equality. So the property of equality means that it's happening on both sides of the equal sign. Okay, and that's just like I tell my algebra kids, it's called opposite operations, right? So essentially what they're trying to do here is they're trying to bring the variables to the same side. Does it matter which side you take variables to? It does not, right? So some people's proofs may look a little bit different based on which side they decide to take the variables to, which side they decide to take the numbers to. Yes? Yeah. Okay, so this is subtraction, property of equality. Okay? What happens going from that line to the next? They simplify, right? They combine like terms, so that's just simplify. Okay, and then going from that line to the next, another subtraction, property of equality. Okay, and then again they have to simplify. And then what's the last one? Division, property of equality, because they divide on each side. So division, property of equality. I guess that's not quite the last one. Then what do? Simplify. Okay, and then what do? It's actually, this one's kind of misleading. It's actually, if you scroll down to the 2.5 notes, it's down there, it's called the reflexive property. Okay, it's called actually no, it's not the reflexive, it's the symmetric property. So the symmetric property just says you can flip-flop stuff around the equal sign. Okay, so we call this the symmetric property of equality. We don't get too intense with like the symmetric property of equality, like, because I feel like all of you know that -1 equals x is the same as x equals -1, so we don't get too technical into those, but it's good to know. Okay, so strategies. Let's talk strategies just briefly. Okay, you want to make sure that you're working through step by step. One of the most common mistakes with proofs. Okay. One of the most common mistakes with proofs is that you assume something before you prove it. okay, I can't use, everybody look up at my screen really quick. I can't use this stuff down here. So I can't just jump from this line right here to this line right here and just say, well, that's subtraction property of equality, because it's not. You didn't prove that you did subtraction property of equality, so that then you can simplify, okay? And that's super important when you get to more of the geometric style proofs, because then it can get kind of confusing based on what you've proven and what you haven't, so what you can use to prove something else, because generally this is kind of a chain reaction. You prove one thing so that you can use it to prove something else, so that you can use it to prove something else, okay? So it's important that we don't skip steps. It's important that we move through these piece by piece, and that we're describing each type, okay? You can do kind of a 2-column proof like this, where you have your step and then justification, and kind of do it that way. Or you can do kind of more of a paragraph proof, where you're writing, that happens by that happens by that. But it just gets a little more wordy to do that. So I don't really care exactly how you guys do it, just as long as you set it up in some kind of logical order, okay? All right, so let's look at the next. Let's just do 1, 2, and 4. Okay, let's just do 1, 2, and 4 on this page. So I'll give you guys some time. You might have to zoom in and make it tiny and stuff like that. I realize there's not a whole lot of room on here, but make sure you do it step by step. Make sure you justify each step, okay? It is absolutely 100% important that you justify each step, all right? Rock and roll. Okay, so let's talk through it. Even if you only got through a couple of them, you still get the general idea, and we can kind of work through them together, okay? So I'm going to talk through my step-by-steps, okay? And I'm going to change the color for my reasons, for my proof. Okay, let's really make sure we're focused in here, okay? So my first step was moving this 5x over to this side. And I did that by subtracting 5x from both sides. So that would be subtraction property of equality, right? And then from there I combine like terms, so I have to simplify next. Okay? So I do the subtraction property of equality, I simplify. From there, since I took variables to one side, I have to take numbers to the other side. So in order to get rid of my negative 7 here, I add 7 to both sides. So that would be addition property of equality. Okay? Then I simplify, right? I combine my like terms. Okay, don't just add in the divide by 2 on this line, right? We got to write out a separate line each time. So to get rid of that negative 2, I have to divide by it. So here's my division property of equality. And then my last step is just simplify for my final answer over there. Okay, any questions? So I know I told you guys, once you've solved regular algebraic equations, it gets kind of annoying to do an algebraic proof. But think about this. This is training your brain to do the stuff that you don't know how to do yet. Okay? So I know it seems a little bit ridiculous to do a proof this way, but this is training your brain to be able to do those geometric proofs that you have no clue how to do, that you would not be able to do without doing this. Okay? All right, let's look at 2 quickly. So first step is, oops, wrong button. First step is I have to distribute, and then I have to simplify. I'm combining like terms. From there, I need to take the x's to the left-hand side, so I do a subtraction. Oh, wait, I messed something up, didn't I? I just realized that I messed up. Why can't I get rid of that? Why is it not going away? Oh, there it started going away. Okay, I forgot to add in, sorry. I should have x. Oops, wrong color. Oh, goodness. This is a train wreck. Okay. So x minus 6, right? I did it on the left-hand side, but I forgot to leave it off on or put it into the right-hand side. So that is my subtraction property of equality. Then I combine my like terms, so that's my simplifying. Okay. Then I have to take numbers to the right-hand side, so that's another subtraction property of equality. Another simplify. And then I have to do my division property of equality. Okay, and then over here, I simplify, and there's my final answer of x equals 4. Okay. Okay, let's go down to the literal equation. Okay, like what we practiced on warm-up. So I have my subtraction property of equality to bring the x term over. And then I simplify, right? The only thing I can simplify is on the left-hand side, because on the right, those aren't like terms. Then I do my division property of equality. And then one more simplify, and then I'm done. So that was actually fewer steps because there was less stuff I could simplify, right? Okay. Now let's take this concept and let's apply it to geometric proofs. Okay, so let's go to the next page. Okay, so let's look here. So we have some properties down at the bottom. Okay, we have some properties down here at the bottom. We have reflexive property. You will almost never use that. Okay. We have symmetric property for both real numbers, segment lengths, angle measures. So I do actually need to make a little bit of a confession. I didn't put very much emphasis when we were doing the basics of geometry, the first unit. I didn't put very much emphasis on the difference between segment lengths and congruency. Okay? So there are properties of equality and properties of congruency. Because in general, if you are talking about lengths, you are talking about equality. If you are talking about this piece is the same as this piece, you're talking about congruence. And the way that you write that is different. Okay? So you can see that there is a difference between let's see, let's look at the segment or the symmetric property for segments, okay? So you can see that there is a difference between this. If AB equals CD, then CD equals AB. There is no line or segment indicator above that, right? Because we are talking about lengths. When we come down to congruence, then we say if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. I want you to see that there are differences there, okay? So if a problem starts off by giving you congruence, you have to move from congruence to segment lengths with the congruent or the definition of congruence, or vice versa. Okay? If they give you lengths and you're trying to prove something in congruence, you have to take the step to go back and forth between those two. Okay? So let's come up here. What two, or I guess we know more than two postulates, right? We know the addition or the segment addition postulate and the angle addition postulate. And then we know those other postulates that we learned last class, the 2-point postulate, right? Any 2 points form a line. We know the 3-point postulate. Any 3 points form a plane. We know the postulates of what can cross what. It might be a good idea for you as you're moving into these proofs to make some kind of separate document on notability and keep all of your postulates in one place. You can copy and paste those note sheets and copy out portions of the note sheets and paste them into a separate notability document where you can keep all those postulates in one place. Okay? So that would be important. Okay. All right, so we are always, in every proof, you are always given something and you are always asked to prove something. So given is where you start, prove is where you get to. Okay? Generally, pictures help. Sometimes they're given to you. Sometimes you have to create your own. But generally pictures are helpful, okay? So let's look at this exploration up here and see what we can make of it. Okay, so we're given that AC is equal to AB plus AB. Okay? So we're given that AC is equal to AB plus AB. Well, we need to know, or we need to prove that AB is equal to BC. So we need to prove that this segment is congruent or equal to this segment. Okay? All right, so if you know that AC equals AB plus AB, that is your given. That's what we start with. Okay? From there, we need to say that we know that AB plus BC equals AC. Why do we know that AB plus BC equals AC? What postulate tells us that AB plus BC equals AC? What do we call these things? AB and BC are segments. AB plus BC, that's addition, right? So the angle addition postulate, you remember the angle addition postulate is the parts add up to the whole. So this part plus this part equals the whole. That's called the angle addition postulate. Okay, so angle addition postulate. Okay, the angle addition postulate. Okay, what happens, so you guys should know this one, what happens going from line 2 to line 3? Come down here, look at your properties. It's one of these properties that are happening down here. If A equals B, it's this one right here. If A equals B and B equals C, then A equals C, right? We came up here, we said, okay, we knew that this was true, and we knew that this was true, so this must be true, right? If AC equals AB plus AB, and AC equals AB plus BC, then we know these two things have to be equal to each other, right? So I proved that AC was equal to this. I also proved that AC was equal to this. So I can prove that the two are equal to each other. That's the transitive property. Property of equality. Okay. Then we get one of our algebraic rules in there. How did we go from 3 to 4? Line 3 to 4. They actually skipped a step based on what I would see, right? They should have done AB plus AB minus AB equals AB minus AB plus BC, right? To do the subtraction property of equality. Okay. Okay, let's look at a couple on the back. Okay, let's look at a couple on the back. I think it's going to be important at this step for me to work through these with you guys. Okay, slow and steady to work through these with you guys for these first couple, and then it's going to be really important. Okay, I know the first unit was pretty easy stuff, and some of you may have not done a whole lot of the preparation, and that's okay, because you didn't need it. I'm going to really tell you, you guys are really going to need the preparation here, okay, because these proofs are not easy, okay. We are going to have kind of a review day next class, so we'll have some more time to practice on these, but it is important for you guys to know what you don't know coming into next class, okay. So let's look at it here. So let's look at the first one here. Oops, wrong button. Okay, so we are given that the measure of angle 1 is equal to the measure of angle 3, right? And what we need to prove, and I'll go ahead and highlight it, is EBA is equal to CBD. Okay, so EBA is equal to CBD. Okay. So, we know, what do you know right now about EBA? What do you know right now about EBA? Do you know anything combined together would make EBA? Do you know anything about either of the angles in EBA? Yes, sir.
EBD and DBA combined to make EBA.
Good. So EBD and DBA combine to make EBA. How do we know that? What did we call that postulate? The angle addition postulate. Okay. So we know that so the measure. Okay, so we said, sorry for the break in the recording there. So we said that EBA is EBD and DBA put together, right? EBD we know is angle 2, right? It's labeled as an angle 2. DBA is measured as angle 3. So let's simplify ourselves a little bit and use those angle 2 and angle 3 instead, okay? So we're going to say measure of angle 2 plus measure of angle 3 is equal to the measure of angle EBA. That's a lot simpler, right? If we use those instead of all the letters in there, that'll make our lives a little bit easier. And then we want to say by, same thing, angle addition postulate. Okay, so the angle addition postulate. Okay, now we've simplified a little bit. That'll make our lives a little easier, especially when we're going through trying to prove in a minute. Okay, all right, and then we moved on in the conversation and talked about CBD, right? So CBD we know is 1 plus 2, again, by the angle addition postulate. So we would say the measure of, well, let me keep with the same colors here. Measure of angle 1 plus the measure of angle 2 is equal to the measure of angle CBD. Again, by colors, by angle addition postulate. Okay. So where do we move from here? What are you guys thinking right now? We need to get so we need to get to where we know that these two things are congruent, right? This and this are congruent. We have given measure of angle 1 and measure of angle 3 up here. We haven't done anything with that, right? So down here we have 2 and 3 together. We have 1 and 2 together. Do you think we could do anything up here that would give us 2 and 3 together, 1 and 2 together? All right. Sorry, somebody just came in and derailed our thoughts. Okay. So could we do anything with this up here, measure of angle 1, measure of angle 3, to make it look anything like what we have down here? Think about, so the theme that we're kind of going with down here is we are trying to add angles together, right? So what if I now said, hey, I know this is given up here, and I can add measure of angle 2 to it. So what if I said measure of, measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. What did I just do there? All I did was add measure of angle 2 on both sides, right? So that would be by addition property of equality, right? All I did was add measure of angle 2 on both sides. Okay, and then a skill that we have here is substitution, right? So if I see that this is equal here, and I see that it's equal here, then I know these two things have to be equal. That's called the transitive property, right? That's what we saw up on the front. If something equals two different things, those two different things are also equal to each other, right? So now I can go ahead and use the transitive property, and I can say that, so you could use it either way. You could use it up with the top and bottom or the bottom two, right? I'll just use this since I see measure of angle 1 and angle 2 right next to each other. So now I can say that the measure of angle, color, keep forgetting to switch color, sorry. The measure of angle CBD is equal to the measure of angle 3 plus measure of angle 2. Okay, so when I see these two things matching right here, I know that these two are equal to each other, right? When I see those two things matching right there, that's when I know those two things equal to each other. You want me to move it up? You guys having trouble seeing? Okay, and we know that this is by the transitive property of equality. And then now we know from substitution, or again the transitive property, since CBD is equal to 3 plus 2, or no, I guess this would purely be substitution, right? So we see up here that 2 plus 3 is equal to EBA. So here 2 plus 3, I can plug in EBA here. So that's going to be my distribution property. So I say measure of angle CBD equals, and I'm just going to substitute in for 2 plus 3. I'm going to substitute in measure of angle EBA by substitution. And that's what I was trying to prove, right? Measure of angle EBA is equal to the measure of angle CBD. So you have to be a little bit, how do I put this? You have to be a little bit creative on how you get there, okay? You can always try to work backward. You can always try to kind of move forward and backward, those different types of things, to kind of try to work there, okay? I'm going to go through the second one with you as well because it has the conversion between equality and congruence, okay? And I want you to be able to see that, okay? So let's look at the second one here. Okay, so it gives me that B is the midpoint of AC, and it gives me that C is the midpoint of BD, okay? So B is the midpoint of AC. What does B being the midpoint of AC mean? Yep.
That AB and BC are congruent.
Okay, let's start there. So we know that AB, so segment AB, is congruent to segment BC. And this is by definition of midpoint. Okay, so that's the definition of the midpoint. Okay, and then we switch from, because we see down here that our proof is not in congruence, and it's in equality, right? So congruence and equality they're kind of two different things. Okay, but we know by the definition of congruence, since this is congruent, these two things have to be equal. So then we would go to AB without the segment marker is equal to BC. And then we would say by definition of congruence. Okay. So we had AB was the same as BC, and then we moved to definition of congruence. We can do the same thing with our second given statement. Our second given statement is that C is the midpoint of BD. So then we would say BC, segment BC is congruent to segment CD. And then again, by the definition of midpoint. Okay, and then we go to equality. So we go from congruence to equality. So now we would say BC is equal to CD by definition of congruence. Okay, so congruence to equality, congruence to equality. Now, do you see a way that we can get A, B, and CD together? So we're really trying to focus in on this line and this line, right? Because that's where our equality statements are. Do you see a way that we can get A, B, and C, D together? Yep.
Maybe I can't. I think it's the
Transitive. Yep.
property, because if AB equals BC and BC equals CD, then that means AB equals CD.
Very good. So when we see these two things matching, then we know the things that they're equal to can match, right? So now we would be able to say AB equals CD and by the transitive property. Okay? So you're trying to work yourself into a way that you can use a definition or postulate that you have. Okay? So a couple things that are important here before we end notes. Okay? It is important, absolutely important, that you start to become more familiar with the properties and postulates and definitions that we're able to use. Okay, all of the properties and postulates and definitions are all on either the notes that we've taken these couple times or the notes from the first unit. Okay, so it's going to be important that you kind of get used to those and get familiar with those. Second thing, make sure that you don't use anything down below in a proof that you have not already proven up above by a definition or postulate or property. Okay? So this is going to be your first chance to kind of practice on your own with the preparation, but it is going to be absolutely crucial that you do practice on your own. Okay? Even if you're a little bit confused right now, it's good to work through some of those things. Okay, and then we'll be able to regroup and kind of review back through it next class, okay? All right, rock and roll.